Okay, John, here's where the fun begins. Now we're going to talk about how to deal with this problem. So I know we have the three phases of contamination. We've got particles, germs, and gases. We've mentioned that many, many times. Let's start with the particles. And let's talk about the difference between what a filter is and what an air cleaner is, because there's a substantial difference when you look at what it can do.
And a lot of confusion from what I hear about with technicians today.
That's correct, absolutely. So really what you get down to is we've got all kinds of different filters on the market. We've got, passive filters. We've got the pleated filters, electrostatic filters, all the stuff you can buy at the Home Depots and the hardware stores today. And then we got air cleaners too. And there's a dividing line. We've got some really good air cleaners out there that we're going to talk about. So, but before we get to talking about the air cleaners and the filtration, let's talk about what we're breathing to begin with. Because what we breathe is really, really small. 98% of the particles you're breathing right now, whether it be indoors or outdoors, measures below 1 micron in size.
Well, and that's important for a number of reasons. The most important reason is that the American Lung Association tells us that particles that are 5 microns and smaller,
Right.
Those are the ones that actually get in our systems. When we talked about the allergy analogy and how our buckets can get filled up with pollutants that spill over and cause histamines, that's those particles. And that's the majority of what we have in our indoor environment.
Right, so we're trying to take these small particles out of the air, and you can't do it with a filter. They're too small. You can't make the holes that small. 1 micron is 1/25,400th of an inch. So if you took an inch on a ruler and divided it into 25,000 pieces, that's 1 micron.
And that's a pretty tiny sized particle.
Right.
I mean, I think they say even a grain of sand or a grain of salt is anywhere from 70 to 500 microns in size. So something that might look pretty tiny to us, in the grand scheme of things when it comes to particle control, is the size of a boulder. It's,
Right.
it's huge.
It's the large stuff that's in the air, and we want to control both. We talked about protecting the equipment. We don't want big chunks of stuff flying in there. But for our health protection, we want to make sure we get the submicronic particles out of the air. That's 98% of what we're dealing with. So, like you said, 5 microns and below pass through our lungs. So the question always comes up is, what's the best filter on the market? Well, that depends on if we're going to talk about airflow or particle control.
Which are going to be both equally important when it comes to the functionality of the equipment and how we can protect the equipment and the homeowner.
Right. I've been studying this for over 25 years now, and I get the question a lot, Steve, since all this studying is done, what's the best filter on the market? And I said, well, if we're just starting to talk about filters, the best filter on the market is sold at Home Depot, but it's not sold in the filter section. It's sold in the wood section. Just get a piece of plywood, cut it the size of your filter, put it in there. Now you got 100% particle control.
Well, that's great for particles, but what's going to happen to our equipment if we do
Right.
that?
We don't have any airflow. So I know that's an exaggerated example, but let's use the other end of the spectrum. You can also go to a big box store and buy some chicken wire and staple that to the size of the frame that you're going to put inside the air handler. And now we have great airflow. But all you can stop is the beer cans and the sandwich wrappers that the contractor left in there when he was building the home. Other than that, we have no particle control. So what filter manufacturers do is they try to meet somewhere in the middle. They can't put plywood in there. You can't have the chicken wire.
Chicken wire in
Right.
there.
They meet somewhere in the middle. And what they used to do in the old days is just put fiberglass throwaway filters in there. And if you go today to a filter aisle at one of the big box stores, you'll see a whole aisle full of all different kinds of filters. All the way from the $1 throwaway filter to the today a $30 3M Ultra.
Yeah, to me, that's one of the big misconceptions today. And you say it, and I say it, and we still all talk about this. But we talk about these cheap throwaways, or even the blue fiberglass ones that come with our equipment when we get it. But when people are getting filters down at Home Depot, they're spending more money than that. It's a big business. In fact, it's about $650 million a year is what homeowners spend at the big box retailers buying 1-inch pleated filters. There's a graphic that you're going to see that has some pricing in there, which shows that people are paying $10, $19, $24 for a single filter to use in their equipment. And that filter, they all have the same basic technology to them. It's that PWH technology.
Paper with holes.
Paper
right?
with holes, right? They're porous. They have pores of a certain size, and when you start to focus on that, filters that have pores that are larger in size, they're great for airflow. And again, critical functionality for the equipment is going to be the airflow. But anything smaller than those pores is going to zip right through there. It's going to be like a BB going through a chain link fence. It's just not going to be enough to stop it. And so, there's some benefits to the good airflow, but the negatives outweigh the positives by allowing all that dirt to cover over our equipment and causing the premature breakdowns and the inefficiencies.
On the other end of the spectrum, we got filters that have much smaller holes, so they're going to collect more particles, but now they have bad airflow, but the particle count will come down. You're going to have less of the heavy particles in the air. But the key is none of those filters, we're going to talk about the difference between a filter and air cleaner, none of those filters can collect below 1 micron in size. They can't because they would have to make the hole way too small. So in order to collect submicronic particles, you got to use science. You got to use something different. And it's not new. There's some old technology that's been used for years, and we're going to talk about that. And there's some new stuff as well. But there is a way of doing it without blocking the airflow. So when you're looking at what a filter can do, it's the large chunks. It's the drywall dust. It's the sawdust. It's in there. It's here again, the sandwich wrappers and Coke bottles.
All the lovely stuff that the construction workers sweep into the ductwork when
Right.
the new homes are being built.
Well, when we want to, absolutely you want to keep that out of the air and out of the equipment. But what about these submicronic particles? You cannot collect it with a filter without making the holes so small that we're going to block airflow. So therein lies the challenge. So let's go through micron sizes. We already talked about that. Human hair is about 100 microns. There's a couple of different things that you can envision that you can see, but you can't see below 40 microns, so it becomes invisible. But most of the stuff we breathe, when I say most, I'm talking about 99% of it is invisible, 98% below 1 micron. So these are the particles we need to get through our lungs, get into our bloodstream, cause the histamine problem. And so that particle size is very difficult, if not impossible, to collect with a filter. So we've got all these different kinds of filters, from pleated filters, electrostatics, all the allergy filters are out there now, and they all have different ranges of what they can collect on the large particle size. None of them collect submicronic particles. And I'd love
that
to,
even comes from their what they talk about, from their
Right on the
marketing
literature.
that's on there. If you actually look on their literature, it will start to, at some point in time, tell you what particle size it collects down to or at. And those are actually a couple of words to focus on as well, as down to and at are two totally different things.
well, that's a key, because there's people or manufacturers say we collect down to 1 micron. Well, it doesn't say what they collect at 1 micron. They might collect 5% of 1 micron, because all right, we claim down to.
Yeah, once in a blue moon, a
Yeah.
small micron
Might
particle
get
runs into
stuck
something.
in there, right?
Yeah.
What does it collect at that size range? So when you're reading literature and reading competitive literature, whether it be a filter or an air cleaner, what are they talking about? When they say down to, that means one thing. At means at that size, we're going to take X amount out. So that's important to know. Good point. So when we're looking at all these kinds of filters, there's really only, I'd love to sit here and tell you that we have the only air cleaner on the market that works, but there's some good technology. There's really 6 that I'm aware of that, and other different configurations and names, but they're the Dynamic Polaris Media Air Cleaner. You've got the Train Clean Effects, Lennox Pure Air, Carrier Infinity, Lennox Pure with the MERV 16,
Right.
Aprilaire 5000, the old electronic air cleaners, which we're all well aware of,
And there's still a lot of them out there,
Right.
and there's still a lot of them going in today.
and HEPA filters, if you bypass it. HEPA is a filter that works with just passive collision, but it is a filter that has the holes that are so small, it's going to stop the airflow. So, but we can use that, and we'll talk about it later on a bypass mode. So those are the 6 technologies, or 7 technologies that we're aware of that can collect 97 to 99% at 0.3 microns, and all of the big chunks, basically.
Right, but it's those small ones that we really want to focus on. And again, if filters just don't have the capability of being able to capture those things. And if you look at the math or some of the numbers that are used on that, if 98% of the particles are below 1 micron in size, and no filters can capture particles below 1 micron, well, even the best filters on the market today, those 5-inch pleats and the 3M filtrettes, they're only capturing 2% of the particles that we have in the air. They're missing the other 98%.
Well, that doesn't make them a bad filter. It
No.
just doesn't make them an air cleaner. That's
Right,
all.
they're just doing what their technology allows them to do, whereas the technology of an air cleaner allows it to capture 97% of
And
those other particles.
Which that's the particles that are injurious to our health, that we're having
Absolutely.
health challenges with. So, we got the smaller particles here again, the 5 microns and below, that's what passes through our lungs. So we need to address that if we're going to get into asthma and allergy relief or health concerns. And here again, we didn't invent the first air cleaner. It was invented in 1932.
Yeah, it's been around for a long time.
A little bit before my time. But, I know way before
Certainly
your time.
before mine.
So in 1932, they created the first electronic air cleaner, which had a just similar to what it is today. You had a wire mesh screen that stopped the big chunks and has ionizing wires that charge the particles. And then it had these collection cells.
Now,
Well,
Steve, let me ask you a question here real quickly. Why did they put ionizing wires in? I mean, particles already have a charge to them, right?
Right. Well, think of it this way. Have we learned anything new scientifically since 1932?
I would like to hope so.
Every 3 months, my phone I've got is out of date. So we're constantly creating new stuff. So we learned some new things scientifically. What we didn't know back in 32 that particles were already charged, positive and negative. Today we know that. So what they said, well, if we charge them, then we can collect them with the opposite charge. That's why they have ionizing wires. They to charge particles prior to them hitting these cells. The cool thing about this is it allowed for good airflow. It had positive and negatively charged plates that grab the particles out of the air while the air is going by. Okay, good airflow, great particle control at the same time. So that's a benefit.
So the challenge with electronic air cleaners is they're great right out of the box. I mean, a lot of these things are 95 to 99% efficient at cleaning particles out of the air when they're brand new, but they start to, as they capture particles, they lose their efficiency. And
Quickly.
Yeah, and certain manufacturers lose them faster than others because of how they collect them. But when it comes to cleaning them, that's really the difficult thing. We all know that homeowners don't change filters every month like they're supposed to. They leave them for 6 months or a year at a time in a lot of cases when they're just not supposed to. Well, with electronic air cleaners, they never clean them. They just think somebody else is going to do them. And at best, if they do try and clean them, they might try and spray them down with a hose or put them in the dishwasher.
Right.
And is that really going to get...
It doesn't take the plated particles. People have to understand that these particles are plating, meaning they're being bonded to, they're stuck to the cell. Vacuuming, spraying with a hose, putting some soap on it
It's kind
doesn't
of like
remove it.
soldering two pieces of metal
Right.
together is essentially what's happening with those
You
particles.
can remove the solder, heat it up, use a chemical. Paint is plated to a wall. You can remove it with paint thinner.
Mm-hmm.
You can't take a vacuum cleaner and remove it. It's plated. It's stuck to it. So,
But it's hard to get off.
but because it's hard to get off is the reason it cleans the air. It's important to take something out of the air, bond it to something, and don't release it back out. So that is the key. It's a great product in that it can take the submicronic particles out of the air, allows for good airflow, which air cleaners do.
Which is what we want.
We want that, but we want it to last longer. If you have somebody that's religiously cleaning them every 30 days, they got a good air cleaner. But what happens is it's efficient for 30 days, and it goes like this, and it drops off, and then it's not working for 9 months
Right.
until someone cleans it.
Well, and I think that's where some manufacturers is they've changed not necessarily the technology, but they've changed the collection mechanism. And
The design of the product.
yeah, which is a great thing to do, and it has allowed them to collect particles for a longer period of time. It's an upgrade in that technology, like you talk about cell phones changing every few months. They've changed that technology, but the challenge still remains the same. They need to be cleaned, or else
Right.
they're going to lose their efficiency, and they're no better than a filter at that point.
Well, what the new EACs have done is they instead of using ionizing wires, you get rid of that and they use these probes, ionizing needles.
Mhm.
Okay, you got a ionizing section on steroids, an area where we don't need to charge anyway. Mother Nature charges the particles. They're already charged positive and negative. So really you don't need that section. We do need the 50,000 little holes in the honeycomb cell that's there to collect the particles as they're going through there. So when you have a collection cell that's that thick and has these little holes in there, and these holes are called flues. So the flue's about that long. And if you look into the flue, it's got a positive side and a negative side. And as the particles with good airflow are flowing through here, they'll get either collected to one side or the other side of that cell.
And they still get electroplated, though, right?
Which, yes, they have
Yeah.
to in order to remove them from the air. So now you got a true electroplating happening, which is awesome. That's what we need to do. The old electronic air cleaners, they have about, if you measure the size of the metal cells, it's about 46 square feet of metal. We've got in the Train Clean Effects and the AccuClean has 334 square feet of filter.
So a massive amount, a huge
It's huge.
difference in the collection area, meaning
Right.
it's more efficient for a longer period of time.
And it's going to
the
stay
time
there.
frame of it, yeah.
But, you're going to be 95, 99% efficient at these smaller micron sizes all the time, and it doesn't degrade in efficiency until about 9 months. So the challenge there is you still, just like the electronic air cleaner cells, you got to clean them. So how do you clean them? I mean, Google it. Go look at how do you clean train clean effects, and you'll find people vacuuming or spraying it with a hose or. So
Does Google show you a little brush tube and cleaning out all the single little flues?
can you imagine 50,000 holes going in and cleaning it?
Yeah, plenty of time out there.
Yeah,
Plenty of
you
time.
can't.
Yeah.
You don't have the time or the effort to do it. So really, to clean it out, they say to vacuum it. Well, that'll take the dust out, but plated particles are bonded or stuck to it. You can't suck them out. If you could, don't you think the air blowing through it on a daily basis would blow it off?
Yeah.
So it's stuck. It's electroplated. That's a good thing. But now you have to remove it. If you can't use any chemicals or anything to remove it, even though you got the longevity, you're still going to have it decrease in efficiency, just like our product or anybody else's product will decrease in efficiency depending on how long it's designed to last.
So in theory, it's a great product, and to maintain it, if you really wanted to maintain it to its peak performance, you'd have to change out the cell,
Right.
the collection cell.
Once a year, every 9 months to a year. So,
Mhm.
and it may not be affordable for everybody, but if it's $600 to replace the cell and you're saving $2,000 a year between energy costs and medication, that's not a bad investment.
Mm-hmm.
And now you got duct modification and things like that, but at the end of the day, if you're looking for a product that can work, that is a technology that works.
It's just going to be kind of expensive to maintain for the homeowner over the long haul of having that product in their
Right.
home. No.
So let's talk about polarized media air cleaning. They're celebrating about their 32nd year in business now. So this is not an old technology like the electronic air cleaners, and it's not new like some of the new stuff that's out there today. It's been out for 32 years now.
But
and
it is true air cleaning technology.
Right.
This is
It's
not a
improved.
1-inch filter.
Right. It's different today than it was 32 years ago. There's a lot of improvements we've made in it. But I want to go through technically how that works because it's a plating product as well. So you've got one right here on the table. What we've got is a 24-volt air cleaner. The guy's just wired it right into a transformer. Now, it imparts a voltage through a titanium cell here. We use titanium, so basically it lasts forever. There's other competitors that use galvanized metal that burns up over a period of time. With titanium, we got that lifetime warranty between that and the potted electronic board. But let's talk about how it works first before we get into the features. You got air coming through here, right?
Mm-hmm.
We need good airflow, so we open up the airflow here by using a diamond-shaped screen. So this screen here will allow for better airflow than the old screens that were like the screen on the screen
Yeah, it was
door.
kind of a mesh screen.
Right.
But the other challenge with that mesh is that it could tear.
Yeah,
If
we
it
got
got
that
caught
call
on
out.
something, it could actually tear if it got hooked onto a J channel or something. So
Right.
with
So-
this, there's just absolutely no way that can happen.
So with the power head, once they wire it in to a transformer from 24 volts, it steps up the voltage to 6,500 volts of DC energy. So now we got positive and negatively charged particles. We don't need to ionize them. They're already charged. So they're coming through here, and we're allowing the air to come through, but then we're grabbing the particles, just like the honeycomb cell, just like the metal cells. We're plating it to a carbon and a low oil content, high glass content fiberglass. When you got a high glass content, it's able to accept the charge from the carbon.
Mm-hmm.
Fiberglass is not conductive, but it's dielectric. It can hold a charge if you induce one close enough to it, and that's what we're doing here.
Right, and the carbon itself also has an additional benefit, right, of being able to, once it's activated, it can collect a few VOCs and odors. It's not a huge amount, but about 40% of the VOCs.
I
and
always
odors.
tell the technicians, don't oversell it. We've got other products that could take the balance of
Yeah,
VOCs.
much better, but it has some effect.
Right, it's
too.
got a small slice of carbon in there. So, I mean, to truly remove a lot of VOCs out of the air for a long period of time, you need blocks of carbon, which we do have that as well. But really the reason for the carbon is to conduct electricity, so off this probe. So now we got air coming in, plating particles, just like everybody else. So what's going to happen? Eventually we're going to lose our efficiency.
Right.
I'd love to stand here and tell you this is going to last for 2 years, you don't have to change it. But about every 3 or 4 months, you're going to have to open these up and change the media.
But Steve, I see that as a benefit for the homeowner. It's homeowners know that even though, again, they might not be changing their filters when they should, they know that they need to be changed out. And by changing this out every 3 to 4 months, there's no cleaning, no scrubbing, no harsh chemicals, no putting it in the dishwasher, no hoping it works the same way again. You put a brand new media pad in there, it's right back up to its peak efficiency, and it doesn't matter whether the panel itself is 6 months old, a year old, or 5 years old, or 10 years old. If it has a new media pad in there,
Just like a brand new air
it's
cleaner.
like a brand new air cleaner every single time.
And it takes
and it's
seconds.
affordable.
Boom,
it takes
boom.
seconds to do,
Right.
and it's affordable for the homeowner. At the end of the day, it's probably really no different than what they're spending on filters.
Well, I saw a stat not too long ago. It says the average person 20 years ago used to spend about $20 a year on filters. Now it's $120 a year. Because they went from buying dollar filters and changing them once a month to buying 18, 20, 25,
Right.
$30 filters. That's what people are buying today.
Mm-hmm.
So like you said, John, this is in that same price range when you look at replacement media. So it's very palatable to what people are used to paying today for our filter, and this is an air cleaner
Mm-hmm.
with some VOC removal as well. So a couple other things that we did, remember the old ones used to have little clips here, and those clips used to get caught inside the filter.
I can tell you from personal use out in the field that trying to slide those in, and so not every system, but in certain systems that might have just been a little bit tighter, those clips would absolutely get caught. In some cases, they'd break off if a homeowner were
they
really
would flip
started
up,
to.
they'd get stuck, and you try to pull it out, and they'd be forcing it out, and it would break.
Mm-hmm.
So now we just hidden the clips. They're hidden right behind the power head here.
Yep, right in the
And
top
they're
channel.
heavy duty, and they're real easy to open up. The power head itself is a potted electronic board. You can see it on the graphic screen here. We use potted electronics, meaning that an open electronic board, if you put it in ductwork, it's going to have moisture, mold, mildew, dust, dirt, and debris landing on it.
It's going to be susceptible to all the different
it'll
nasty
land on it.
components.
Unless
that
you
are in
clean
there.
it off every 30 days, it's eventually going to heat up and burn out.
Right.
So a potted electronic board takes that same electronics, actually we beefed it up a little bit, and puts it in a mold, and you pour plastic over it, and it hardens, and it's protected. When you see our power head, you don't see the electronic parts. It's protected. So this thing's bulletproof.
Yeah, it's not just a box that's built around it. It's injected into it. It's a solid piece at that point.
Right. Okay, so that's some of the details. There's really three ways that this polarized media air cleaner works. It works like a regular filter, which we call passive mechanism. So why don't you give them an explanation on how that is?
Well, passive is like any other filter that we've talked about, guys. We have airflow moving through the duct system itself. We've now put something that's going to be in the way of that airflow, and that airflow is going to run into it. And then whatever chunks of dirt and dust and debris and all those tiny particles that we have, they're going to run into that. Now, the smaller ones, unfortunately, because they don't get captured, they're just going to continue to keep going. But the filter itself just isn't doing anything. It's a passive collection mechanism. Well,
So even if this is unplugged, it's got a passive,
it's going to
mechanism,
act like
right?
a standard filter in there.
Right. So when we plug it in, or we get the wired in, and now we got 24 volts coming to it and 6,500 volts of energy, like we talked about, something's happening in here. It's called polarization.
Right, and polarization is just really we've got the charged carbon center screen, and we've got all the fiberglass hairs that are in here. They now have a polarized charge to them, meaning anything with a polarized charge has a positive and a negative charge to it. And keep in mind that means that any one of those fiberglass hairs can pick up any particle. It doesn't matter if it's a positive particle or a negative particle. Any particle
They
can be
just wrap
captured.
themselves around it.
Yeah, they wrap themselves around every single one of those fiberglass hairs. And not only does it do it once, but it can do it about 10 times over again.
See, that's a key. That's how we get 3 or 4 months out of this. Say, well, geez, it looks like the big giant electronic air cleaner should last longer than this. How do you get that longevity?
And that's because of the way that it holds the particles on there and the efficiency that it has
Well,
with
the
that.
technology is called polarization. So picture a magnet, grabbing paper clips. Now, if I lined up a bunch of magnets on a table here and touch one of them, they all become magnetized out to a certain point.
Yeah, it's like
right?
a little paperclip chain.
Right. Now, even though this magnet 10 or this paperclip 10 paper clips away from the magnet, it's not touching the magnet, it's still magnetized.
Right.
That's what happens with these. As they wrap around, they can hold 10 times its mass in particles. So that's how we get our longevity.
Right, but you'll notice on that same paperclip chain that last paperclip, it doesn't have as much of a magnetic hold
it
as
gets
the
weaker.
other one does. And
Right.
eventually it gets to the point where it could fall off. And that's what we don't want to have happen to this. And that's why it should be changed out at regular intervals. And most people, I think, remember quarters best. And that's why we say typically about 3 months at a time. But
Right.
this works through a third mechanism as far as capturing the particles, which is what we call the agglomeration process.
Which is really interesting because they didn't design it to happen this way.
Yeah, it was kind of a byproduct
Right.
from what you've said about it and from what
Which
I've
is kind of
learned
cool,
on it.
actually.
Yeah, well, what agglomeration is, first, guys, is that when particles move through here, some of those smaller particles. Remember, this captures particles at 0.3 microns in size. Some particles are going to be smaller than that, so they're going to be able to move through the air cleaner. It could be 0.1 micron, 0.2 microns in size. Well, as those things move through the air cleaner, they pick up a polarized charge. So now they both have a positive and a negative charge to them. Well, as those particles now start to move downstream, whether it be in the ductwork or whether it be in our breathing space, other particles that have a positive or a negative are now going to be attracted to that polarized particle, causing it to become a larger particle. It agglomerates or it clusters together in a larger group. And while it's not so heavy that gravity pulls it out of the air, it is large enough that on the next pass, and remember with all air cleaners, they're multiple pass systems. It's not just one loop. On the next pass, as that larger particle, it's now 0.3 microns in size or larger, it can then be pulled on and electroplated
Right.
onto the collection or the media pad that's in there.
Right, like you said, it's not a single pass efficiency filter or air cleaner, and neither is any of the other ones we talked about. But if you want to graphically look at it, as you're seeing on the screen now, here again, picture a magnet. This is basically a magnetic field. So a couple things have to happen. When it's magnetically charged, just like a magnet grabbing paper clips, you can hold them, and if I took a magnet and had a bunch of paper clips here and I grabbed them, you'd see the paper clips hanging there, right? Now, if I shook it hard enough, the paper clips would fall off. What you need, secondly, is a heavy enough voltage to take those paper clips and basically melt it onto the magnet. That's what voltage you do.
The
So
stronger the voltage, the more holding capacity it's going to have.
right, so we have the polarization, the magnetic field grabbing it, stopping them, and holding it, and then we have a high enough voltage to plate it, to stick it to it. So what you're seeing here on the screen is the 0.3 microns and the 0.1s that are getting trapped up in there. Now these 0.3s, some of them get through, some of the 0.1s get through, because it's not 97% on every single pass. So the cool thing of the agglomeration is, here again, it acts like almost like an ion, and it can grab negative and positive particles as they're floating around the air, making it larger. And the cool thing also is it doesn't just face load. You get those 1-inch pleats, there's nowhere for the dust to go. We truly have 1 inch of filter media here, and these load from the inside out.
Mm-hmm.
So we can hold a lot more dust before it starts affecting its pressure drop.
It's kind of like when you've gone from using a 1-inch pleated filter to a 4-inch pleated filter. You just have so much more surface area. And that is a true inch-thick surface area versus just having a thin little sheet of paper that's been creased into, it's a 1-inch frame, but the media of most filters it's paper thin.
Right, exactly. So when we have that passive control, we have the 3 different mechanisms. Now we can truly take submicronic particles out of the air in a 1-inch design, easy to install, all the benefits not only for the contractor but for the homeowner. And there's different ways of putting it in. We could put it in filter grills and grills on the side of walls, and you can also have
as long as it's
installations here.
as long as it's a 1-inch filter back
Slot.
return grill, you can use it in there. So guys, in most areas of the country, this is just simply, it only draws about 2 amps of power. So you're going to wire this back to the board itself, and it comes with the wire that you're going to use. If you need additional wire, which 99% of the time you won't, you can just splice a little 18-2 thermostat wire to it. But you're just going to wire it hot. So you're just going to wire back to the control board where you can get your 24 volts for that, and it's just going to slide right in the 1-inch filter slot on the return. If you have media cabinets, they make what they call retrofit models, which are designed specifically for that cabinet. So be sure what that cabinet is. If it's a SpaceGuard 2200, for example, make sure you ask for the 1-inch panel that fits. It's the retrofit model that fits the SpaceGuard 2200 or 2400, whatever it is. But it'll be designed to fit perfectly within that media cabinet so that it's not flopping around, there's no blow-by. It's essentially, it is the same air cleaner, it just has a track system built on the top and the bottom of it. So you have retrofit models, and as Steve already mentioned, you also have your 1-inch filter back return grills. So whether that's used inside of the house, it might be sometimes easier to just wire that back to the thermostat versus the furnace itself, but it gives you a lot of different options to where this can be used. And I'm not sure if we mentioned this or not, but there's over 50 different standard sizes of this to fit all brands and makes and models of equipment. So there truly shouldn't be too many custom sizes out there, but sometimes you do run into an odd one. And you
And
know
we'll
what?
do them in quarter-inch increments.
Yeah, the good thing about that is we'll make a custom size for you. If you look through those 50 different sizes and there's truly one that's not going to meet your needs, we'll make one for you. It takes a little longer to get, so make sure the homeowner knows that.
And that's usually on the commercial end. Residentially, I don't know what our percentages are, but I guess believe it's a small percentage. In the old days, it wasn't. We started off with 5 standard air cleaners, and as we got into the southern markets, and we had different size of filter grills and stuff. As we got to a size got to be in the hundreds, we would make it a standard size, and we kept doing that over time. So over 32 years, we end up with 50 plus standard sizes, meaning they're all the same price.
Yeah.
Now we still here again, we can still do custom sizes if we have to.
But at the end of the day, guys, the benefits for you and the homeowner is that it is a true electronic air cleaner. It captures 97% of the particles at 0.3 microns in size. It's easy to install. I mean, in most cases, 20 minutes is about your typical install time with that. It's easy to maintain for the homeowner, and it's always going to work at peak efficiency as long as that media pad is being replaced. And by the way, that also means an additional call for you as the technician. You're going out there on the service call or the maintenance call, and that homeowner has an air cleaner in there. Once a year, they're going to get their media replacement. So that's going to help you increase your average service ticket or your average maintenance ticket for that particular homeowner.
Yeah, and we talked a lot about filters that block airflow, and one filter that does, a true filter that can collect submicronic particles, because it does have small enough holes, is called a HEPA filter. High efficiency particulate arrestants or high efficiency particulate air. There's different ways that people name the acronym, but we can use a HEPA on a bypass mode. So we've got a product that has its own blower motor. It's got about 560 CFM, but once you put the air cleaner in there or the HEPA filter and the pre-filter, it'll reduce that to about 300 CFM. That's enough CFM to pull about 35% of the air out of the return, put it through the pre-filter, then through the blower wheel, and then right through the HEPA and put it right back in. So here again, this is going to be multiple pass efficiency. But it's the ultimate air cleaner when you want to combine things, when people have really severe asthma allergies, or they might just say, my doctor says I got to have a HEPA. Is that a HEPA? Well, no, but it's polarized media air cleaner. I have to have HEPA. Well, we've got it. But you still have to put something in line.
Yeah, something still has to be in line with the equipment. Remember, the HEPA is going to pull airflow out of the ductwork. So it gives you zero static pressure with it. But it's a fantastic tool for pulling particles out. But at the end of the day, there's nothing right in front of the equipment, protecting the equipment. So you still need to have something like the polarized air cleaner at the equipment itself to help protect that equipment from the larger stuff that might be running into it. It's also capturing the smaller particles. And then you've got the HEPA that's a 99.97% efficient at capturing those smaller particles.
So you got like
in
a
size.
double whammy going on
Absolutely,
here.
yeah.
So,
It is the biggest and the ultimate type system a homeowner can get for particulate capture.
so that basically covers filtration versus air cleaning. In our next module, we're going to get into germ control and odor control, talking about ultraviolet energy.